The collapse of a military doctrine often begins not with a scream of panic, but with a quiet, dismissive chuckle in a darkened room. In a fortified intelligence compound outside Moscow in 1978, a group of Soviet officers gathered to examine a set of grainy, stolen schematics detailing the United States' newest armored vehicle. They looked at the blueprints of the future, saw a 60-ton machine powered by an aircraft engine, and convinced themselves they were looking at a magnificent American failure. The laughter that filled the briefing room was not manic, but born of a deep, professional confidence. The men at the table were veterans of the Great Patriotic War and the architects of the Cold War's most formidable armored force. They understood the brutal realities of tank warfare: mud, diesel, steel, and numbers. To them, the tank was a tool of mass production, a rugged sledgehammer designed to be churned out by the thousands in the factories of the Urals. When the colonel at the head of the table tapped the projection screen with his wooden pointer, he focused on a single, baffling detail of the American M1 prototype. The Americans were attempting to fit a gas turbine engine, technology reserved for helicopters and jets, inside the hull of a main battle tank. The critique offered by the Soviet intelligence analysts was rooted in the practical logic of the Eastern Front. They noted the weight of the proposed American vehicle, which tipped the scales at nearly 60 tons compared to their own sleek T-72s, which weighed just over 40 tons. They argued that such a heavy beast would sink into the soft earth of the European theatre, drowning in its own mass before it ever reached the Fulda Gap. They looked at the fuel consumption projections for the turbine engine and found them absurd. The sheer volume of aviation fuel required to keep a division of these tanks moving would strain a logistics chain to the breaking point. To the Soviet mind, the XM-1 was not a weapon. It was a diva, a complex and fragile technological indulgence that would require a team of aerospace engineers just to change the air filters. This assessment was comfortable because it reinforced the existing Soviet worldview. The T-72 was viewed as the pinnacle of armored evolution, low-profile, diesel-powered, carrying a massive gun, and simple enough for a conscript to operate. The leadership in Moscow closed the file on the American program with a sense of relief. They believed the United States had fallen into a trap of over-engineering. The production lines in Nizhny Tagil continued to hum, churning out diesel tanks that fit the doctrine of deep battle and overwhelming numbers. No one in that smoke-filled room could imagine that their dismissal of the turbine engine was the first step toward a catastrophe that would unfold in the desert 13 years later. However, what the Soviet intelligence officers did not know was that the exact same laughter and derision were echoing through the halls of the United States Congress and the Pentagon. The decision to put a turbine engine in the Abrams tank was not a unified American vision. It was the subject of a vicious internal war that nearly killed the tank before it was ever built. Senior American generals, men who had cut their teeth on the diesel-chugging Patton tanks of previous wars, viewed the Honeywell AGT-1500 turbine with the same skepticism as their Soviet counterparts. The arguments in Washington were heated and existential. Critics pointed out that a tank is not a jet fighter. A turbine engine runs hot. Its exhaust is fierce enough to melt asphalt or burn a soldier standing too close, and it consumes fuel even when the tank is idling. In the late 1970s, as the prototypes were being tested, the program teetered on the edge of cancellation. Powerful factions within the Army leadership demanded that the turbine be ripped out and replaced with a conventional, reliable diesel engine. They argued that the range anxiety alone would paralyze an armored advance. The logic was sound, the costs were high, and the political pressure to revert to the safety of diesel was immense. Yet, a small but stubborn faction of engineers and armor officers refused to yield. They saw something in the turbine that the spreadsheets could not capture. They looked past the fuel economy and saw a revolution in mobility. A diesel engine builds power slowly, fighting against the friction of pistons and the weight of the vehicle. A gas turbine delivers instant torque. It allows a 60-ton monster to accelerate with the snap of a sports car. It enables the tank to rush from a standstill to 20 miles per hour in seconds, a capability that would allow for a new kind of shoot-and-scoot tactic that traditional tanks could not match. Furthermore, the turbine offered a stealth advantage that was counterintuitive for such a loud engine type. At a distance, the high-pitched whine of the turbine dissipated much faster than the low-frequency rumble of a diesel engine. The Abrams would eventually earn the nickname Whispering Death because it could approach a battlefield without the ground-shaking throb that usually heralded an armored column. While the skeptics worried about gallons per mile, the proponents argued for survival through speed and silence. They believed that the ability to reposition instantly would save more crews than a fuel-efficient engine ever could. The survival of the turbine engine was a testament to a specific American institutional culture that differed sharply from the Soviet model. In the Soviet Union, design was driven by a centralized, top-down consensus that favored evolutionary improvements and low risk. In the United States, the chaotic interplay of private contractors, military requirements, and political oversight allowed for a radical gamble to survive the bureaucracy. The engineers at Chrysler Defense bet their reputations that the logistical burden of the fuel-hungry engine would be outweighed by its dominance in maneuver. This was the Great Divergence of 1978. On one side of the world, the Soviet Union committed itself to the perfection of the known, the diesel engine, the autoloader, and the philosophy of mass. On the other side, the United States committed itself to the potential of the unknown, a complex, high-maintenance power plant that promised to change the physics of how a tank moved. The Soviet analysts in Moscow had laughed because they judged the Abrams by the standards of the past. They did not realize that the Americans were building a machine for a future that had not yet been written. As the 1970s came to a close, the two superpowers had placed their bets. The Soviets had thousands of reliable T-72s ready to flood across the plains of Germany. The Americans had a small, controversial fleet of turbine-powered tanks that many of their own generals still did not trust. The stage was set for a collision of philosophies, but the true nature of the disparity would remain hidden for another decade. The laughter in Moscow faded, replaced by the rhythmic clanking of production lines, while in Detroit and Lima, Ohio, the first turbine engines began to whine, hungry for air and fuel, waiting for a war to prove who was right. While the debates over fuel consumption raged in the public halls of Washington, a far quieter and more secretive chapter of the story was unfolding in the humid forests of Maryland. At the Aberdeen Proving Ground, shielded from both the budget cutters in Congress and the spy satellites of the Kremlin, the Ballistic Research Laboratory was conducting a series of experiments that would fundamentally alter the equation of survival. The engineers gathered there were not firing standard American ammunition at American steel. Instead, they were preparing to test the limits of a new material against the very best weapons the Soviet Union could export. The ammunition being loaded into the test rigs was not theoretical. It consisted of captured Soviet rounds, armor-piercing, fin-stabilized discarding sabot rounds, and high-explosive anti-tank warheads taken from T-62s and T-72s during the conflicts in the Middle East. These were the lethal claws of the Soviet bear, the rounds that had devastated Israeli tanks in 1973 and were designed to punch through the thickest cast steel NATO could produce. The target downrange, however, was not a block of steel. It was a slab of a revolutionary new composite material born from a British invention known as Chobham armor, which the Americans were adapting for their new M1 prototype. When the order to fire was given, the physics of the impact defied the expectations of traditional metallurgy. In a standard engagement, a tungsten penetrator hitting steel acts like a nail hitting wood. If it carries enough energy, it pushes through. But when the Soviet tungsten darts struck the composite layers of the new armor, they did not penetrate, they shattered. The complex matrix of ceramic tiles, steel plates, and elastic layers encased within the armor absorbed the kinetic energy, dispersing the shockwave laterally rather than allowing it to bore through. Even the chemical energy of the heat rounds, jets of molten copper designed to burn through metal, was neutralized by the internal geometry of the slab. The results at Aberdeen were stunned silence followed by frantic calculation. The engineers realized they were not just looking at a better shield, they were looking at a material that rendered the current generation of Soviet ammunition obsolete. This was the secret that the GRU analysts in Moscow, staring at their stolen blueprints, could never see. A spy satellite might measure the dimensions of a tank, and an informant might steal a fuel report, but neither could peer inside the molecular structure of the armor plating. To the Soviets, the 60-ton weight of the Abrams was evidence of clumsy American engineering, a sign that the tank was too heavy to move. To the engineers at Aberdeen, that weight was the physical cost of invulnerability. This technological divergence was merely the surface symptom of a profound philosophical divide separating the two superpowers. While kilograms of armor and horsepower figures filled the technical reports, the true difference lay in how each nation valued the machine versus the human inside it. The Soviet Union, shaped by the traumatic loss of millions of men in the Second World War, designed tanks as tools of mass warfare. Their doctrine of deep battle viewed the tank as a disposable asset, a unit of combat power to be spent in exchange for territory. The T-72 was built to be low, small, and cheap enough to be produced in the thousands. If a tank was lost, it was simply replaced by the next one coming off the rail line. In contrast, the United States was designing the Abrams as an ecosystem. The American doctrine, which would eventually evolve into air-land battle, operated on the assumption that they would always be outnumbered. Therefore, they could not afford to trade tank for tank. The Abrams was designed around the survival of the crew, based on the belief that a trained team of 4 tankers was the most expensive and irreplaceable component of the weapon system. This philosophy dictated that the machine had to be complex, integrated, and robust enough to take a hit and keep fighting. The Abrams was thus built on 3 pillars that were completely alien to Soviet thinking. The first was the composite armor that turned enemy fire into shattered fragments. The second was the controversial turbine engine, which offered the ability to dictate the pace of the battle through superior mobility. But the third pillar was perhaps the most radical, the integration of advanced sensors and a digital fire-controlled computer. Where the Soviet tank relied on the gunner's skill and optical rangefinders, the American tank was beginning to rely on a digital brain that could calculate wind, temperature, and lead angles instantly. This created a paradox that the Soviet leadership failed to grasp. They looked at the Abrams and saw a vehicle that was everything they despised: heavy, complicated, and thirsty. They saw a logistical nightmare that would bog down an army. But the American designers saw a predator. They saw a machine that could move faster than the enemy's decision cycle, survive hits that would vaporize a T-72, and deliver lethal fire with mathematical precision. The disconnect was total. The GRU believed that the Americans were building a bunker on tracks, a defensive behemoth that would be outmaneuvered by swarms of agile Soviet tanks. The Americans believed they were building a land-based spaceship, a system where the technology shielded the crew so they could do the work of killing. This blindness on the part of the Soviets was not accidental. It was the inevitable result of measuring a new enemy with an old ruler. They assumed that the laws of physics that governed steel armor, where thickness equals protection, still applied. They did not understand that the rules had changed, and that the slabs of armor on the front of the Abrams were not just metal, but a complex technological answer to a brute force question. As the prototypes moved from the proving grounds to production, the secret of the armor remained locked inside the steel casing. The Abrams entered service with a classified skin, a black box of protection that no drill bit or welding torch in the maintenance depots was allowed to touch. The Soviets continued to produce their T-72s by the thousands, confident in their numbers and their doctrine, unaware that the balance of power had already shifted in the quiet forests of Maryland. They were preparing for a boxing match against an opponent who had brought a shield they couldn't break and a philosophy they couldn't understand. Meanwhile, thousands of miles away from the quiet forests of Maryland, the theories of armored warfare were being tested in the unforgiving laboratory of the Middle East. Throughout the 1980s, the border between Iran and Iraq became the scene of a brutal, protracted conflict that bore a closer resemblance to the trench warfare of the First World War than the high-tech battles of the future. It was here, amidst the marshes and the dust, that the Soviet Union found what it believed to be the ultimate validation of its design philosophy. The T-72, the very tank that American intelligence feared and respected, was being used in combat by the Iraqi army, and the reports filtering back to Moscow were cause for celebration. In the hands of Iraqi crews, the T-72 was performing exactly as the Soviet designers had intended. It was robust, it was lethal, and in head-to-head engagements, it was proving to be a dominant predator. The Iranian army, equipped with British-made Chieftains and American-made M60 patterns, tanks that represented the previous generation of Western armor, found themselves outmatched. Iraqi officers sent glowing reports to Baghdad, describing how their 125mm main guns punched through the armor of the Western tanks with terrifying ease. In the flat deserts and the contested border towns, the silhouette of a T-72 became a symbol of invincibility for the Iraqi Republican Guard. For the military analysts in Moscow, these battlefield reports were the confirmation they had been waiting for. They looked at the burning hulks of Western tanks and saw proof that their dismissal of the American Abrams program was justified. The logic seemed irrefutable. If the T-72 could destroy the M60 and the Chieftain, which were the mainstays of NATO forces at the time, then the Soviet doctrine was sound. They believed that the simple, rugged design of their tanks, produced in massive numbers, was superior to the over-engineered complexities of the West. The victories in the Iran-Iraq war created a dangerous feedback loop of confirmation bias, convincing the Soviet high command that they held the winning hand in the poker game of the Cold War. However, the lessons learned in the deserts of Mesopotamia were fatally flawed because they ignored the context of the fight. The victories of the T-72 were not achieved against the cutting edge of Western technology. They were achieved against older machines operated by crews that had been depleted by post-revolutionary purges in Iran. The Iranian tanks lacked the advanced fire control systems, the modern ammunition, and crucially, the thermal sights that were becoming standard on the new American Abrams. The engagements were fought largely in daylight, at visual ranges, where the gunner's eye and the optical rangefinder were the primary tools of the trade. In this specific arena, the T-72 was indeed a formidable beast, but it was fighting a war of the past, not a war of the future. This illusion of strength blinded the Soviets to the single most critical revolution taking place in American tank design: the mastery of the electromagnetic spectrum. Back in the design bureaus of the United States, engineers were not just obsessing over turbine engines and composite armor, they were fundamentally changing the way a tank saw the world. They were integrating thermal imaging sights that did not rely on visible light. A thermal sight detects the heat difference between a tank engine and the cool desert sand, creating a crisp, glowing image, even in total darkness or through thick smoke. To the Soviet mindset of the 1980s, night fighting was a clumsy affair, involving active infrared spotlights, giant lamps mounted on the turret that projected a beam of infrared light invisible to the naked eye, but visible to anyone with night vision goggles. Turning on an active IR spotlight on a modern battlefield was akin to lighting a flare in a dark room. It allowed you to see, but it also announced your exact location to every enemy for miles. The Soviets assumed that night combat would be a chaotic, short-range brawl. They simply did not ask the question that kept American commanders up at night. What happens when the enemy can see you clearly from 2 miles away, but you cannot see him at all? The GRU analysts continued to focus on the tangible physical metrics of the Abrams. They wrote reports about its heavy fuel consumption, mocking the logistical tail required to keep it moving. They criticized the complexity of its electronics, predicting that the delicate circuit boards would fail in the harsh conditions of field deployment. They measured the thickness of the steel and calculated penetration values based on the physics they understood. But they failed to measure the invisible advantage of information dominance. They did not understand that the laser rangefinder and the ballistic computer on the Abrams had eliminated the guesswork of gunnery. In a T-72, a long-range shot was a calculation of art and luck. In an Abrams, it was a mathematical certainty. This divergence in perception created a tragedy of expectations. By the end of the decade, the Iraqi army had emerged from its war with Iran as the 4th largest military in the world, battle-hardened and confident. Their commanders believed they were the masters of armored warfare. They believed their T-72s were the apex predators of the desert, capable of crushing any Western force that dared to intervene in the region. They had defeated Western tanks before, and they were certain they could do it again. They sat in their command posts in Baghdad, drawing up defensive plans based on the lessons of the last war, digging revetments, and planning kill zones based on line-of-sight visibility. Unbeknownst to them, they were marching toward a technological cliff. The confidence that had been cultivated in Moscow and exported to Baghdad was built on a foundation of obsolete data. The T-72 was a champion of the industrial age, a brawler designed for a slugfest in the mud. But the machine that was quietly deploying to the staging grounds of Saudi Arabia was a creature of the information age. The illusion of invincibility that surrounded the Soviet armor was about to be shattered by a reality that neither the Soviet advisors nor their Iraqi students had ever bothered to imagine. The stage was set for a collision not just between two armies, but between two eras of history, and the side that believed it was strong was about to discover that it was already blind. By the early weeks of 1991, the theoretical debates that had consumed the Pentagon and the Kremlin for a decade were replaced by the stark reality of deployment. The vast, flat expanse of the Saudi Arabian desert became the staging ground for the largest concentration of armored vehicles since the Second World War. On one side of the line, the Iraqi army, hardened by 8 years of war and equipped with the best hardware the Soviet Union could export, dug into the sand. The Republican Guard, the elite corps of the Iraqi military, assembled their heavy divisions, the Tawakkalna, the Medina, and the Hammurabi, to create a wall of steel designed to stop the coalition advance cold. The Iraqi disposition was a textbook application of Soviet defensive doctrine. Their commanders, trained in the academies of Moscow and Baghdad, approached the coming battle as a problem of geometry and mass. They constructed extensive berms and revetments to protect their tank hulls, leaving only the thick turrets of their T-72s visible. They pre-calculated firing arcs for kill zones based on the maximum visibility of a clear desert day. Their strategy relied on the assumption that the Americans would be forced to close the distance to engage, entering a lethal envelope where the T-72's heavy 125mm gun could trade blows on equal terms. They believed that the desert, like the steppes of Russia, would be a contest of grit and eyesight, a place where the defender held the advantage. Facing them was a force that looked entirely different, both in silhouette and in philosophy. the US 7 Corps had arrived with hundreds of M1 Abrams tanks, the fully matured version of the controversial prototype that had sparked so much laughter years earlier. These machines were equipped with the heavy uranium-depleted armor mesh that had been tested in secret, and they hummed with the high-pitched whine of the gas turbine engines. But the most critical difference was not on the outside, it was on the inside. The American crews sat in air-conditioned interiors watching the world through the glowing green and black screens of their thermal imaging systems. They were not preparing for a visual brawl, they were preparing for a calculated assassination of enemy armor. On February 26, 1991, nature intervened in a way that seemed to favor the defender. A massive weather system known as a Chobham descended upon the battlefield, whipping the desert floor into a frenzy. A wall of sand and dust, rising thousands of feet into the air, swept across the region, blotting out the sun and turning the bright afternoon into a choking, murky twilight. Visibility plummeted to less than 100 yards. The wind howled with such ferocity that it drowned out the sound of approaching engines. To the Iraqi commanders peering out of their vision blocks, the storm was a blessing. They believed that no aircraft could fly and no laser rangefinder could work in such conditions. In their minds, the sandstorm had paused the war. Inside the Iraqi tanks, the crews relaxed. They assumed the Americans, reliant on high technology, would be blinded by the grit and the dark. Many Iraqi units turned off their engines to conserve fuel and save their filters from the dust, settling in to wait out the storm. They trusted that the weather provided a cloak of invisibility, a natural shield that would force the enemy to wait for clear skies before attempting any maneuver. It was a reasonable assumption based on the history of warfare. Since the time of the Romans, armies had rarely attacked when they could not see their own hands in front of their faces. But the Chobham was not a shield for the Iraqis, it was a lens for the Americans. Inside the turrets of the lead elements of the US 2nd Armored Cavalry Regiment, the view was serene, detached, and terrifyingly clear. The thermal imaging sights of the Abrams tank operate on a different spectrum of physics than the human eye. They do not see light, they see heat. And in the cool, swirling dust of the storm, the heat signature of a heavy tank stood out with blinding clarity. The sandstorm, which scattered visible light and blinded optical sights, was almost transparent to the thermal sensors. To the American gunners, the battlefield did not look like a brown haze. It looked like a field of high-contrast ghosts. The Iraqi tanks, even those with their engines idling or recently turned off, retained immense amounts of heat in their steel armor and engine blocks. Through the thermal sight, they appeared as bright, glowing white silhouettes against the dark, cool background of the desert floor. The Iraqi crews, believing they were hidden by the storm, were actually broadcasting their positions as clearly as if they were shining spotlights into the night. The very weather that they thought was their ally had turned them into perfect targets. The American columns began to move forward, cutting through the wind. The gas turbine engines of the Abrams, notorious for their thirst, proved their worth in the heavy sand. The torque allowed the 60-ton behemoths to push through the dunes with an agility that the lighter diesel tanks struggled to match. The noise of their approach was swallowed by the howling wind, masking the sound of the tracks and the turbines. They moved like phantoms, rolling steadily toward the coordinates of the Republican Guard divisions. The tension in the American turrets was disciplined and quiet. The commanders and gunners spoke in calm, clipped phrases over the intercom, identifying targets that were still miles away. They could see the heat plumes of Iraqi exhaust. They could see the warm barrels of artillery pieces. They could even see the body heat of soldiers standing outside their vehicles, unaware that they were being watched from beyond the horizon. The discrepancy in situational awareness was total. One army was blind, deaf, and huddled against the elements, waiting for the weather to break. The other army was moving with predatory confidence, using the storm as a cover to close the distance to lethal range. As the afternoon wore on, the distance between the two forces collapsed. The Americans crossed grid line after grid line, moving deeper into Iraqi-held territory. The Iraqi sentries, peering into the swirling brown dust, saw nothing. They heard nothing. They remained secure in the belief that the battle was hours or days away. They did not know that the technological gamble made in the 1970s, the bet on complex sensors and digital fire control, was about to pay off in the most dramatic fashion possible. The storm had created a one-way mirror in the middle of the desert, and the collision that was about to happen would not be a fight, but a revelation. The wind screamed across the desert floor, carrying with it a wall of abrasive sand that turned the afternoon sky into a suffocating twilight. It was 4:20 p.m. on February 26, 1991, and in the middle of the Iraqi desert, visibility was practically zero. To the human eye, the world ended at the hood of the vehicle. Beyond that, there was only a swirling brown void. The Iraqi commanders of the Tawakalna division dug into defensive positions along a map coordinate known as 73 Easting, believed they were secure. They assumed that in these conditions, where the naked eye was useless, the war would pause. They waited in their revetments, engines idling or off, trusting the storm to hide them until the air cleared. But a few hundred yards away, cresting a shallow rise in the terrain, the lead elements of Eagle Troop of the U.S. 2nd Armored Cavalry Regiment were moving forward. Inside the turret of the lead M1 Abrams, the gunner peered into his thermal sight, and the brown chaos of the storm vanished. In its place was a crisp, monochromatic landscape where heat was the only color that mattered. The sight, piercing through the obscuring dust, revealed a picture that would have been terrifying if it weren't so clinically clear. There, spread out before them in a perfect shooting gallery, was an entire battalion of the Republican Guard. The thermal image revealed the T-72s not as camouflaged steel beasts, but as glowing white shapes against the cool background of the sand. Every engine that was running, every exhaust pipe that was still warm, and every metal track link that had gathered friction heat stood out like a beacon. The Iraqis had dug themselves into the sand to lower their silhouette, a tactic that worked perfectly against optical sights. But against thermal sensors, the earthworks provided no shelter. The heat signature of the tanks radiated straight through the gloom. The American crews found themselves staring at an enemy force that was completely unaware of their presence. The engagement that followed was less of a battle and more of a systematic dismantling of a military doctrine. The American commander gave the order to fire, and the Abrams gunners began the sequence that had been drilled into them on the ranges of Germany and the United States. They laid the crosshairs on the glowing center of mass of the nearest T-72. They pressed the button for the laser rangefinder. The laser, traveling at the speed of light, cut through the dust, bounced off the Iraqi armor, and returned instantly. The fire control computer absorbed the data, range, wind speed, vehicle tilt, ammunition temperature, and in a millisecond, it adjusted the gun barrel. There was no manual elevation, no guessing the distance, no bracketing the target with a test shot. The solution was mathematical and instantaneous. When the 120-meter main gun fired, the sabot round left the barrel at over 3,500 miles per hour. It was a dart of depleted uranium, a dense, heavy metal, designed to sharpen itself as it penetrated armor. It crossed the 2-kilometer gap in less than 2 seconds. The Iraqi crews never heard the shot. The projectile arrived before the sound of the muzzle blast. The impact was catastrophic. The uranium penetrator punched through the frontal armor of the T-72 as if the steel were wet clay. Inside the turret, the kinetic energy converted into blinding heat and pressure, instantly igniting the propellant of the Soviet tanks' stored ammunition. The result was a violent phenomenon known to tankers as the jack-in-the-box effect. The immense pressure of the exploding ammunition inside the T-72 blew the turret completely off the hull, sending the multi-ton component cartwheeling into the air. Through the thermal sights of the American tanks, the desert floor began to light up with sudden, blooming flowers of white-hot energy. One tank exploded, then another, then a third. The silence of the storm was broken by the thunder of detonations, but to the Iraqis, the source of the destruction remained a mystery. They saw their comrades exploding next to them, but they could see no muzzle flashes through the dust. Panic began to set in among the Iraqi ranks. Some crews, realizing they were under attack but unable to locate the enemy, began firing blindly into the sand, sending shells arching harmlessly into the dunes. Others, paralyzed by the suddenness of the violence, never managed to fire a shot. They were fighting a ghost. They swung their turrets frantically, searching for a target, but their optical sights showed only the brown swirl of the sandstorm. The advantage of the thermal sight was absolute. The Americans could see the panic, the movement, and the confusion, and they methodically engaged each new threat with the same dispassionate precision. The speed of the destruction was difficult to comprehend, even for the men pulling the triggers. In a span of roughly 23 minutes, Eagle Troop, consisting of 9 Abrams tanks and 12 Bradley fighting vehicles, annihilated a heavy armored force that outnumbered them significantly. They destroyed nearly 30 tanks and dozens of other armored vehicles. The engagement ranges were often well beyond 2,000 meters, distances that Soviet doctrine considered extreme for effective fire, especially in poor weather. Yet the Abrams were scoring first-round hits with nearly 100% accuracy. When the shooting finally tapered off and the burning hulks of the Republican Guard illuminated the darkening desert, the disparity of the outcome became clear. Not a single Abrams tank had been destroyed, not a single American crewman in the troop had been killed by enemy tank fire. The Battle of 73 Easting was not a fight between peers, it was a collision between two different centuries of warfare. The T-72, the champion of the industrial age, had been rendered helpless by the information age. The thick armor and heavy guns of the Iraqi tanks were irrelevant because they could not complete the most basic requirement of combat. They could not see what was killing them. Later, when reports of the battle were analyzed by military observers and eventually filtered back to the remnants of the Soviet Union, the reaction was one of quiet horror. A Soviet colonel, reviewing the details of the engagement, was reported to have said, "This is not a tank, this is something else." He was right. The machine that had swept through 73 Easting was not just a tank in the traditional sense of a mobile gun, it was a predator that lived in a part of the electromagnetic spectrum where the enemy could not exist. The laughter that had once echoed in Moscow over the turbine engine and the fragile electronics had been silenced forever, replaced by the crackling sound of ammunition cooking off in the desert night. If the engagement at 73 Easting was a chaotic knife fight in a dark room, the confrontation that followed the next day was a calculated execution in the light. Beneath the lingering haze of the battlefield, the Medina division of the Republican Guard waits in a sprawling defensive line, known as Medina Ridge. This is not a hastily assembled rearguard, it is the armored fist of the Iraqi military, the best equipped and best trained formation remaining in the theater. They are deployed according to the strictest tenets of Soviet military science, entrenched in hull-down positions that minimize their exposure while maximizing their fields of fire. They have artillery support, logistical depth, and the desperate motivation of men defending their homeland. On the morning of February 27, 1991, the 2nd Brigade of the US 1st Armored Division moves to meet them. This is the moment the Soviet Union had spent 40 years preparing for, the hypothetical clash of titans that was supposed to happen on the plains of Germany, now transpiring on the sands of Kuwait. The weather has cleared enough to allow for visibility, removing the blindness excuse of the previous day. The Iraqi commanders believe that in this conventional setup, where lines of sight are open and the terrain is flat, the heavy gun of the T-72 will finally prove its worth. They believe that if they can see the enemy, they can kill him. But as the American formation crests the ridgeline, the geometrical nightmare of modern warfare reveals itself once again. The battle does not begin at the ranges the Iraqis expect. It begins at distances that defy the ballistic tables taped to the walls of the Soviet design bureaus. The American gunners, utilizing their superior optics and digital stabilization, begin to identify targets at ranges exceeding 3,000 meters, nearly 2 miles. To a T-72 crew, a target at 3 kilometers is a pixel, a blurred shape that requires a mix of luck and artillery-style elevation to hit. To the Abrams fire control computer, a target at 3 kilometers is a solved equation. The firing commences with a rhythmic, mechanical violence. The long rod penetrators streak across the desert floor, closing the distance in seconds. The Iraqi tanks are hit before they even realize the battle has joined. The revetments they dug for protection become their graves as the depleted uranium rounds punch through the earth berms and the armor behind them with equal indifference. The invincible frontal armor of the T-72, sloped and reinforced, fails to stop the kinetic energy of the American sabot rounds. The turrets continue to fly into the air, creating pillars of black smoke that mark the destruction of the Medina Division's fighting power. However, unlike the previous day, the Iraqis fight back with disciplined ferocity. They are not asleep, they are alert and waiting. As the American tanks close the distance, the Iraqi gunners fire volleys of 125mm shells. Artillery shells hammer the ground around the advancing American column. For a brief window of time, the air is thick with incoming steel. This is the test of the second great gamble of the Abrams program, the secret armor tested in the woods of Aberdeen. In the midst of the chaotic exchange, Iraqi rounds find their marks. Several Abrams tanks are struck directly by high-explosive anti-tank rounds and kinetic penetrators fired from T-72s. In any previous war and against any previous tank, these hits would have been fatal. The sheer energy of a 125mm round is enough to shatter a Patton or a Chieftain. But when the smoke clears from the impacts on the Abrams hulls, the American tanks are still moving. The crews inside report a heavy thud, a ringing vibration, but no penetration. The Chobham composite armor absorbs the blows that should have killed the tank. The ceramic tiles shatter internally to disperse the energy, leaving only scorch marks and gouges on the exterior paint. The psychological impact of this resilience on the Iraqi defenders is devastating. They are doing everything right according to their training. They are firing the correct ammunition at the correct range. They are scoring hits. And yet the enemy machine continues to advance, its turret turning slowly to deliver a retaliatory kill. It is the realization of a tanker's worst nightmare, the discovery that your weapon is a toy and the enemy's skin is impenetrable. The morale of the Medina Division breaks not because of cowardice, but because of the terrifying realization of technological obsolescence. The battle rages for barely an hour, but in that time, the landscape of Medina Ridge is transformed into a graveyard of Soviet armor. The American line advances relentlessly, rolling past the burning carcasses of hundreds of tanks and armored personnel carriers. The discipline of the US crews, aided by the auto-tracking of their fire control systems, allows them to fire on the move, maintaining their momentum while delivering lethal accuracy. The Iraqis, forced to stop to fire accurately, are static targets in a dynamic shooting gallery. By the time the ceasefire orders begin to circulate, the Medina Division has effectively ceased to exist as a fighting force. The desert floor is littered with the burning remnants of the Soviet Union's best export technology. The final tally of the engagement is a statistical anomaly that historians will study for decades. In the largest tank battle since World War II, involving thousands of armored vehicles and tens of thousands of men, the number of M1 Abrams tanks destroyed by enemy tank fire remains absolute: 0. This figure, 0, is the final, undeniable indictment of the industrial age philosophy. It is not a rounding error, it is proof that the ecosystem of the Abrams, the integration of the turbine's mobility, the computer's vision, and the composite armor's protection, created a disparity so vast that it broke the logic of attrition. The Soviet doctrine assumed that in a clash of thousands of tanks, both sides would bleed. Medina Ridge proved that in the information age, it is possible for one side to kill without bleeding. For the observers in Moscow, reading the after-action reports that would eventually emerge from the Gulf, Medina Ridge was the final nail in the coffin of their worldview. 73 Easting could be dismissed as a fluke of the weather. Medina Ridge was a fair fight in broad daylight, and the result was the same. The heavy metal beast of the steppes had been slain by the digital predator of the West. The silence that followed the battle was the sound of a superpower realizing that its sword was dull and its shield was made of paper. As the heavy dust of the Shamal finally settles and the ceasefire takes hold across the broken landscape of southern Iraq, a silence descends that is far heavier than the quiet of the desert. The fires from the burning oil wells and the smoldering wreckage of the Republican Guard cast long shadows over the battlefield, illuminating a scene of absolute devastation. In the days and weeks that follow, military statisticians from around the world begin the grim task of counting the costs, and a single, stark set of numbers emerges from the chaos. It is a statistic so lopsided that it initially seems like a propaganda fabrication, a mathematical impossibility in the history of mechanized warfare. The final tally reveals that over 2,000 Iraqi tanks and armored vehicles have been destroyed or captured. The landscape is littered with the shattered remnants of the Soviet Union's export philosophy. In return, the number of M1 Abrams tanks destroyed by enemy tank fire stands at exactly 0. While a handful of American tanks were damaged by mines, friendly fire, or anti-tank missiles, not a single Abrams was penetrated or destroyed by the 125mm main gun of a T-72. The fearsome kinetic rounds of the Soviet arsenal, which had been designed to crack the armor of NATO, had bounced off the skin of the Abrams like hail off a tin roof. For the first time, the world is forced to look at the direct, unvarnished collision of two competing philosophies of war. On one side lay the Soviet model: quantity, simplicity, and disposability. This doctrine treated the tank as a commodity and the crew as a replaceable component, betting that in a massive confrontation, the sheer weight of numbers would overwhelm the enemy. On the other side lay the American model: quality, complexity, and survivability. This doctrine treated the tank as a precious ecosystem, a high-tech platform designed to shield the crew and provide them with an unfair advantage in information and range. In the unforgiving laboratory of the desert, the Soviet model did not just fail, it was obliterated. The reports from Desert Storm reached the diminishing halls of the Soviet High Command like funeral messages for a dying empire. The generals and intelligence officers who sit in Moscow are not just reading about the defeat of an ally, they are reading the obituary of their own military worldview. The turbine engine they had mocked in 1978 as a fragile, fuel-guzzling toy had proven to be a decisive instrument of maneuver, allowing American forces to flank and outrun their opponents. The composite armor they had dismissed as unnecessary weight had proven to be impenetrable. The electronics they believed were too delicate for war had functioned flawlessly, turning the night into day and the sandstorm into a shooting gallery. A classified analysis by the GRU, written in the twilight months before the final collapse of the Soviet Union, summarizes the catastrophe with chilling honesty. It concludes that the decades of investment in the T-72 and its variants were built on a foundation of obsolete assumptions. We prepared for the wrong war, the report effectively admits. They had prepared for a war of visual range and attrition, while the Americans had built a machine for a war of information and precision. The laughter that had filled the briefing room in 1978, the confident chuckles of men who believed they understood the immutable laws of armor, has been replaced by a silence heavy enough to bury a superpower. The M1 Abrams emerges from the smoke of the Gulf War not merely as a successful tank, but as a vindication of a specific kind of courage, the courage to innovate against the grain of conventional wisdom. It was a machine forged from arguments, failures, and political battles, a product of a system that allowed engineers to defy generals and logic, to defy tradition. It proved that in the modern age, a weapon is not defined by the size of its gun or the thickness of its steel, but by its ability to integrate into a larger network of seeing and acting. The Abrams was not just a tank, it was a node in a digital web that the Soviets could neither see nor understand. The legacy of this victory extends far beyond the borders of Iraq. It marks the definitive end of the industrial age of warfare, where victory went to the side with the biggest factories, and the beginning of the information age where victory belongs to the side with the best sensors. The burning hulks of the T-72s signaled the end of the illusion that mass could defeat mastery. The lesson written in fire across the sands was simple and unforgiving. What happens when the enemy can see you and you cannot see him? The answer is not a battle. It is an extinction event. When we look back at the footage of Desert Storm today, the images often feel like they belong to a different world. Grainy, green-tinted clips of silent explosions and burning horizons. It is easy to view it as a triumph of technology, a sterile video game war where the machines did the work. But to stand in front of an M1 Abrams in a museum, or to walk past a rusted T-72 in a memorial park, is to be reminded of the human choices that built them. These machines are physical manifestations of national psychology. The T-72 was born from the trauma of invasion, a desire to build a wall of steel so thick that no enemy could ever breach it again. The Abrams was born from a fear of being outnumbered, a desire to use ingenuity to tip the scales against impossible odds. Both were rational answers to the nightmares of their creators. The tragedy for the crews of the T-72 was that their nightmare had evolved, while their machine had stayed the same. The story of the laughter in Moscow serves as a quiet warning about the danger of certainty. The Soviet experts who dismissed the turbine engine were not stupid men. They were experienced, intelligent, and deeply knowledgeable. But they were trapped by their own expertise, unable to imagine a future that didn't look exactly like the past. They believed that the rules of war were static, that mud would always stop a heavy tank, and that complexity was always a weakness. History, however, has a way of punishing those who mistake their habits for laws. The desert wind that revealed the Iraqi tanks to the thermal sights of the Americans blew away more than just sand. It blew away the comforting illusion that we can predict the next war by looking at the last one. As we move further into a century defined by AI, drones, and cyber warfare, the echo of that 1978 laughter reminds us to listen closely to the ideas we are quickest to dismiss. Thank you for spending part of your day with us to explore this pivotal moment in history. If this journey meant something to you, we'd be honored to have you with us again. Until next time, stay curious and take good care.